So today we're gonna start the class for deep learning smart mobile platform. So for the smart mobile platform class, we're gonna study about deep learning basics at first, and then we're gonna study about the applications of deep learning to multiple mobile platforms. That's our main objective of these classes, okay? And after finishing deep learning, we're gonna study about deep reinforcement learning and reaction control for stabilized learning and the related neural network architectures and federal learning and so forth. So we're gonna cover a lot of topics in this class. But before that, we have to study about the basics of deep learning. So today we're gonna study about that one by one. So this is the first slide what we have. So deep learning revolution is real. It means that last year there is one on so the Yusuf Andrew, Jeffrey Hinton, and Ian LeCun received Asian Turing Award in 2018. So the Asian Turing Award was most well-known and most well-recognized award in computer science. So it means that the deep learning is recognized as the most important topic in computer science nowadays. So from this time, deep learning became the major trends in computer science nowadays. And the technologies in deep learning are widely used for many applications in computer science and electrical engineering, also in many other topics, okay? So before starting deep learning, we have to understand what's the machine learning. So machine learning can be classified into three major topics. The first one is supervised learning, next one is unsupervised learning, last one is reinforcement learning. So in supervised learning, we have to train the model with a lot of data. In addition to that, the data should be associated with their labels. Then we can start the supervised learning. One of the major examples for supervised learning is the classification programs. So suppose that we want to classify between apple and banana. So apple and banana, we can classify both of them by colors and so forth. So suppose that we have to make the classification model at first, and then we have to put a lot of apples over there. So then the model will recognize the main characteristics or main features of the apple. That is the supervised learning. But when you put apple images or apple pictures, we have to let the model know that this is an apple. That's why we have to make labels for the given data. So after putting a lot of apple images and their labels, we have to put a lot of banana images and their labels. And then the model can classify between apple and banana. So that's called supervised learning. Okay, so that is widely used for regression and classification. The next topic is unsupervised learning. Unsupervised learning means that we want to do some learning with some data. However, we do not have labels at this time. So suppose that we have a newborn baby. So and then for newborn baby, we can give something, and then we can say that this is not food. Please do not eat this one. We can say that, but the baby will think that is food. Then the baby will put the object in the baby's mouth, and then he or she will recognize that this cannot be eaten. So it means that even though we are saying that this object is not food, but the label cannot be recognized by the baby. So then baby should take the data at first and make it as a vector, and then they have to do some similarity computation. So the baby knows what is the object, what she or he can eat, and then they have and the data should be represented as vectors, and the vectors should be compared with the current object. And if they are similar to each other based on the vector similarity calculation, then we can think that, okay, this is also food. Otherwise, if the two vectors are not similar to each other, then we can say that the new arrived vector cannot be eaten. So it means that we can do something like intelligent decision based on this vector similarity calculation if we do not have labels. So these kinds of mechanisms are all associated with unsupervised learning. So in unsupervised learning, we can gather all the vectors if they are similar to all together. So then that's called clustering. So in one cluster, all vectors are similar to each other, okay? And we have to think about the dimensional reduction as well in unsupervised learning, because we have to represent all the data with a vector. So the vector can be very can have a lot of elements there, then it means that it is very highly dimensional. It has high dimensional data. But sometimes the high dimensional data will be burdened because even though it increases the accuracy. That's why dimensional reduction mechanisms may be required if we have to think about the efficiency. Okay, so these topics are all belongs to unsupervised learning. Okay. So below you can see also reinforcement learning. So reinforcement learning is very important topic because it is talking about sequential decision making. So in supervised learning or unsupervised learning, our decisions are just for one time. So we can do the classification between apple and banana with supervised learning. We can make a decision whether we have to eat this one or not based on the vector similarity. So those are one-time decision making. But reinforcement learning, we have sequential decision making. So ultimately, we have to reach the goal in order to maximize our profit. However, we have to make a decision sequentially. For example, suppose that we are doing goal play. So during the goal play, we have to put some, we have to do some actions every single state, and then eventually we have to win. So that's why this kind of mechanism is called reinforcement learning. So in addition to that, if we want to escape a maze, then we have to make a decision or we have to make an action as the state changes. That's why this is also related to reinforcement learning. That's why reinforcement learning is kind of sequential decision making in order to achieve our given goal while maximizing our profit. So that's called reinforcement learning. Okay. So we're gonna study about all of these ones. But majorly deep learnings are purely related. Majorly deep learning is related to supervised learning. That's why we focus on supervised learning in this slide at first. And then we will mix some features of unsupervised learning in order to improve the deep learning architecture. In addition to that, for the reinforcement learning, we can solve a lot of reinforcement learning algorithms with supervised learning techniques. That's why deep learning can be used for the reinforcement learning as well. So in summary, we will focus on the supervised learning because supervised learning is kind of baseline of the deep learning. And on top of that, we will add some features of supervised learning, unsupervised learning. On top of that, we have to think about reinforcement learning. So those are all related to deep learning, and these three are major components of machine learning. Okay. So from now on, we have to think how deep learning works. So as you can see, right hand side, the yellow boxes or circles are deep learning modules. So deep learning. So in this case, we have 4 vertical lines in yellow boxes. Yellow box. So those are hidden layers. In each vertical line, we have 7 units. So it means that in each hidden layer, we have 7 units, and we have input as a red ones, and you can see 5 elements in input. It means that our input vector has 5 elements. In addition to that, as an output, we have 4 elements. That means that our output has 4 elements. So that's why here we made some outline, or we made some models at first. Based on this model, we have to put a lot of data. So if our classification task is quite complex, then we have to make this model much more complicated. Whereas if our task is very simple, then we can make the model simple. That's why our first step for deep learning is for setting up deep learning models. We can make MLP, which means multi-layer perceptron. We can make it as CNN, which means convolutional neural network, or RNN, which means recurrent neural network, or GAN, which means generative adversarial network, and so forth. Otherwise, we can customize our network. It means that we can design our own neural network architecture by our own design. So we can define number of hidden layers, number of units inside there. If our task is very complicated, then the number of hidden layer and number of unit increases. So in addition to that, we have to select our optimizer and cost functions. The meaning of cost function and optimizers will be explained later when we explain the basic neural network architecture. Once our model is prepared, then we will put a lot of data inside there. So in input, so next phase is training. For this training, we have to put a lot of data in input and output. So in input, we will put a lot of data. So while we are putting Apple images in input 1,000 times, we have to say that this is Apple 1,000 times. That's why input will be our data, output will be our labels. In a similar way, we have to put a lot of banana image in input as well, and then we have to put a lot of banana labels in output as well. So as you can see in the second phase of deep learning computation, so it is for training, and we can say that it should be with a large scale data set. Okay. So then while we are putting a lot of data there, the yellow circles will have some value. The values are for the classification. So setting the values in yellow boxes is called training. So that's called machine learning training or deep learning training and so forth based on the data. Okay, but suppose and then last one, once the values within the yellow boxes are set, then when we have some input as an arrival in the camera, then we will gonna have some output based on some calculation. The output will be our 4 elements vectors, and the vectors should say this is apple or this is banana. Okay, that's called inference or testing. So that is also called a real world execution. Okay, so then since the values in yellow circles are already set, so once we have some input data, we have some calculation, then we can derive blue values. That is the result, or that is the machine learning computation result. Okay. For the second phase, in this calculation, for the second phase, suppose that you have little number of data. So suppose that you want to make a bed, just like figures in this picture, but you have insufficient data. So in that case, the shape of the bed will be fitted into some specific features, then that is called overfitting. So if we have insufficient data for the training, then we are saying that will make overfitting issue. But the code itself is not wrong, because it makes the model quite precisely, even though the data is not that sufficient. That's why the code itself is not a problem. The problem is that we do not have sufficient data. Suppose that, for example, we want to train the model in order to recognize the apple, but we have only one data and the apple is green. So it means that then the neural network model will think that, okay, the apple is green because our own data is only green. So this kind of problem happens when we do not have enough data. So when we want to solve this one, looking at the code does not help at all, because code itself is fine. Our problem is the number of data. That's why we have to put more and more data, or we have to find another way in order to overcome this kinds of overfitting issue. So that's why overfitting issue will be discussed later, maybe end of this lecture note. Okay. So in neural network, we have two more advanced architecture. The first one is CNN, convolutional neural network, and that is the architecture which can have multi-dimensional input. So before CNN, in conventional neural network architecture, all the inputs should be one-dimensional vectors, but that is quite limited. So in our real world, we have a lot of images or a lot of video sequences. Those are two-dimensional or three-dimensional. That's why in order to recognize two-dimensional or three-dimensional high-dimensional data, we need a new architecture. So CNN is for recognizing multi-dimensional input. That's why that is very powerful in 3D or 2D image processing. That's why we are saying that is useful for visual information learning. So on the other hand, recurrent neural network RNN is for recognizing the time-dependent information. So in neural network architecture, there is no variable which can recognize the time information. But as you can see over there, so neural networks are connected to each other with some timeline. That's why that is useful for time-dependent information. That's why we are saying that recurrent neural network is for time series information processing or learning. That's why two of these architecture have their own characteristics. That's why they are widely used for their own applications. In addition to that, we can think about the visual learning. The first visual learning is the first example of visual learning is object recognition. As you can see below, so we can see a lot of green bounding boxes in order to recognize vehicles. So that's called object recognition. So next one is style transfer. As you can see in the left-hand side, you have digital camera image in A. The A can be converted to B, C, or D by taking the style of individual artist. So then we can change the image to the figures that can be drawn by the artist. That is possible because the neural network model can learn the style of artist painting. So based on the style, we can convert the digital image just like that. So this is very powerful application services in computer vision. So deep learning denoising is enhance the quality of the images based on the deep learning architecture. And then if we have some automotive driving or driving car, and we have some real-time camera image sensing over there, and then we have a lot of images. The images may have blurs or noises because on driving we have rain, we have snow, we have nighttime driving, and so forth. So in order to enhance the quality of the images, we have to make deep learning and denoising techniques. So those are all possible by deep learning nowadays. Lastly, we have super resolution. That means that we have to enhance the resolution of the images. So that's called super resolution. Okay. So in speech and language learning, we can think about speech recognition, machine translation, information retrieval. So it means that so those are all all related to speech or time series information processing. That's why those are majorly applications of recurrent neural network techniques. But CNN also is applicable for these applications if the data itself has a high dimensional format. So in addition, we can think about the generative adversarial network. So as you can see, the left-hand side, we have two competitors. The first one is generator, the next one is discriminator. Generator will make a lot of data. So based on the data, they will make some sample. And then the discriminator will check whether that is real or fake. So if that is determined as fake, then the generator will start to improve its own data in order to fool the discriminator. But discriminator should be able to improve its own ability as well in order to do much more clear or precise classification. So they are competing, so they are improving their own abilities by themselves, and then eventually generator can make very nice sample, and then if we eliminate the discriminator, then we can make a neural network which can generate something. So that's why that is called generative adversarial neural network. The term of generator is used, generative is used because we are making something, generator, and adversarial means that they are comparing to each other. That's why this is called GAN, and we have two neural network, generator and discriminator. They will compete, and then finally generator can make very nice sample based on the learning result. So these are all we have to study during this class, okay? So then here, in order to realize deep learning theory into real worlds, then we have to understand how we can handle the software about that. So here we will gonna study about the software examples, okay? So in this case, we have to make an addition of two variables. So we will gonna use TensorFlow. So TensorFlow is one of the well-known software library for deep learning computation. That's why in this lecture we majorly studying about TensorFlow, and lastly we will gonna study about the Keras as well. So TensorFlow, Keras both are very widely used, and that's why they are very powerful. And they are you can find a lot of source code for TensorFlow and Keras. So for the first line, we have import TensorFlow STF, which means that when we want to use some functions defined in TensorFlow library, we have to type tf dot and so forth. Then we can use the functions within the TensorFlow library. In line second, we have comment, so we can skip the line second. Line 3, we have a new variable that is called node1, and node1 is tf.constant, which means that we are now use the function constant, which is defined in TensorFlow library, and the value itself is 3, and dtype means data type. Data type is integer 32-bit. And the line 5 and line 4, we have similar definition, node 2, that is defined by tf.constant, and the value is 5, and this is also integer 32-bit. And the next line, line 5, we have new variable node 3, and then we have new function that is called tf.add, which means that we are going to add two variables over there, and the result should be stored in node 3. So within the add function, we have node 1 and node 2. Then it means that we will take the value of node 1, which is 3. We will going to take the value of node 2 as well, that is 5. and then we will add both of them. Then the result will be 8. The 8 will be stored in node 3. Okay, so that is the usage of constant function defined in TensorFlow. So here, so data type itself in node 1, node 2, node 3 is TensorFlow type. So the data type is tensor. So that's why, because they are the return values of tf dot something functions. So node 3, line 3 and line 4, node 1, node 2 are return value of tf dot constant. In line 5, node 3 is the return value of tf dot add function. That's why the function return values should be tensor type. That's why node 1, node 3, 2, node 3s are the types of these three variables are tensor. So in order to get the values of tensor, you have to make a session in TensorFlow. That's why in line A, you have to make a session. So you are defining new variable that is called SESS, and that should be a session variable. That's why we have to call the session. That's why SESS has tf.session function, and then session is now activated. So in line 9, we have to print out node 1, node 2, and session run. So then in the end of the print, within the print, you can see that SESS.run, RUM means that it should take the real value of the tensor type variable. So inside there, you have node 3, that's why you will take the value of A. Value of node 3, that's why it should be A. And then once we are done for any kinds of calculation, you have to close the session. That's why line 11, you can see session.close. So in this time, we will close our session. So left-hand side, we are defining 3 variable node 1, 2, 3, and we are creating session in line A. Line 9, we will gonna execute the node 3, and then we'll take the value. And line 11, we'll close the session. So this is what we saw in our previous slide. So right-hand side, we have exactly the same code over there, but we have different session definition. So as you can see in right-hand side, in line A, we are creating session, and we have a with loop. So within the with loop, when we have indentation there in line 9, then we can execute the node 3 value, and we can print out the result over there. So the meaning of right-hand side, and left-hand side are same to each other. I'm sorry. Equivalent to each other, but the coding style is different. So that's why this is your choice. You can pick one based on your preference. Both are fine. That's why you can use one of both. But most likely in this lecture note, we are using the style as you can see in the right-hand side. Okay. So here we have another definition that is called placeholder. In placeholder, let me see how it works. In line first, we are defining TensorFlow. That's why when you type tf.something, that is the function which is provided by or defined by TensorFlow library. So line 4, we have tf.placeholder. It means that you are holding a place. It means that you can reserve the memory size. However, there is no values yet. So in line 4, you have new variable A, and that is tf.placeholder. Then you will reserve the place, and those places are integers. And the shape is 3, 1. So the first value is for vertical, second value is for horizontal. That is the common in Python. That's why vertically we have 3 spaces, horizontally we have 1 space, as you can see right-hand side figure. In line 5, you are defining new variable B, and that is also for tf.placeholder. That's why we're going to reserve some places, and the places should be integer, and the shape is 1, 3, which means that in vertically we have only 1 space, or horizontally we have 3 spaces. That's why, as you can see in the right-hand side figure, B has 1 by 3 vector. And then line 6 in C variable, that is the return value of tf.matmul, which means matrix multiplication, and then it has A and B. So A is 3 by 1, B is 1 by 3. That's why we can do the matrix multiplication, and the result will be 3 by 3. The result will be stored in C. But however, we have no values yet. That's why the actual calculation is not happening at all at this time. In line 9, we are creating session. In order to some calculation for tensor type variables, we have to make a session. As you can see in line 4, 5, and 6, our variables A and B and C, all of them are tensor because those are the return values of tf.some functions. That's why the tensors should be executed in session. That's why we have to make a session. That's why in line 9 we are creating a session. And we have a tab in line 10. That's why we have indentation and we have print. Inside there, we are executing session.run. So inside there, we have variable C. That's why we want to execute line 6. For line 6, in order to execute C, we need A and B because that is the return value of tf.matmul A, B. That's why we can get the value of C when we have A and B values. That's why in order to calculate the C, we need to get the values of A and B. That's why we have to put the values of A and B. So for that purpose, we have another argument that is called feed underbar dict. And then we have braces. So inside there, A should be 3, 2, 1. So 3 has some array notation, 2 has array notation, 1 has array notation. Those means that in each stage, we have value 3, 2, 1. That's why that is fit into 3 by 1 matrix and array. And in B, 1, 2, 3 are in one array. That's why 1, 2, 3 has 1, 2, 3 is 1 by 3. So A should be 3, 2, 1. B should be 1, 2, 3. The values should be stored in A and B. That's why we have the value of A and B now. That's why we are now possible to calculate the C value exactly. That's why C will be, as you can see, in the right hand side below. Then we can print out the result over there. So this is the very simple introduction to deep learning and machine learning, and then this is very simple introduction to how you can use the TensorFlow. So in TensorFlow, we have many more functions inside there. However, this is very good starting. This is enough for making some basic code in our next stages. So once we study more and more, we will gonna study more and more functions in TensorFlow. So you don't need to worry about too much at this moment, and only understanding these features should be enough in this current stage. Okay. So so for the next time, we're gonna see what is the linear regression, what is the binary classification or logistic regression, and lastly, we're gonna study about the softmax classification. And then we are ready to study about the neural network. Once we understand what is the neural network at the time, we will gonna add more and more hidden layers. We're gonna add more and more functions over there. Then we can start to have a deep learning framework. So once we are familiar with the deep learning framework, as we mentioned before, we're gonna study about CNN, RNN, GAN, and then we will be fine with deep learning software implementation from that time. So that should be our good starting point for the deep learning computation. Okay. So next time, as I told you before, with the title of linear function, we're gonna study about linear regression. We're gonna study about binary classification. We're gonna study about softmax classification. Okay. And then for next, we're gonna study about neural network, convolutional neural network, the further complex data format to train CNN that is called Cypher10. We're going to study about that as well. Lastly, we're going to study about the recurrent neural network that is called RNN. So as an advanced topic, we're going to see what is the GAN, generative adversarial neural network, and then we're going to see the mathematical meaning of neural network. That's why we're going to study about the interpolation, though that is one of the main topics in numerical analysis. And then we're going to study about PCN LDA. That is those are for dimensional reduction, and that is also associated with neural network architecture. Then we're going to study about that as well. So as we mentioned before, even though the code is perfect, but the amount of data is not sufficient at all. Then we may face the problem that is called overfitting. So lastly, we're going to see what is the overfitting and what is the major solution approaches to overcome overfitting. So that should be studied lastly, but that is also related to PCA, LDA, neural network architecture, and the theory about that. So we will gonna study about these stuffs for deep learning. After studying about deep learning, with this lecture slide, we will gonna study about deep reinforcement learning, federal learning, and the other topics. That's why in this lecture, we're gonna study about many other topics except these kinds of basic deep learning functions. So please stay tuned and please try to do your own exercise as much as possible. So every single lecture, I will gonna explain more and more about the TensorFlow programming or Keras programming. That's why I hope you can do the programming by yourself. That should be very helpful for you. Okay. So thank you very much for today. Then we're gonna study one by one from linear regression from next time. Thank you.